So far we have discussed about the correlation and the correlation part and the cross tabulation part. Correlation, quickly revised, there are the 4 or 5 things. First, starting with core, which find out the relation between the any two variables, which are metric. Second, core dot test. It not only checks the relation, it also find out for the hypothesis whether this R is equal to 0. P value, that's probability value. Hello. Sorry, I was disconnected. Let me share the screen once again. So we were talking about the 5 things, 5 sort of functions in RStudio. When we are working with okay, Shipra, is it audible now? Okay, and are you able to see my screen? On my screen, it's RStudio there. So we are talking about the 5 things. I hope I will be able to complete this sentence this time. So these are the 5 things. The 5 things are starting with core. Any two variables you can find their relation. Core dot test. We can find the relation, and also null hypothesis checked whether the R is equal to 0. At this point, I want you to please remember, whenever in the statistics I say test, 2 things are compulsory. Number 1, we are checking whether any 2 or more things are different or not. So whenever I say test, it means compulsorily there will be 2 things, and we are checking whether the 2 things are different or not. So if I'll go outside the statistics of this chi-square test, t-test, f-test, if I'll go for blood test or sugar test or any other sort of the test, basically you check, one is your body parameter and one is which is the parameters of a healthy body, whether they are significant different or not. So these days we are given some sort of report. In the report, maybe you have no idea about what should be the sulfur, how much sulfur should be there, but some report things are written, and if your value falls between those 2 limits, you say, well, I'm good. So from that perspective, we also create some limits here. So if your data, the 0 comes between that, it means whatever you are checking, that is almost equivalent to 0. These are some, since I have not discussed hypothesis you guys, these are just some conclusions which you need to remember. Whenever you see any word like p value, do you know 4 or 5 things are happening parallelly there? The moment there is something called the p value, anywhere you find, it means there is a hypothesis test compulsory. P value is always with the test, nothing else. So hypothesis testing will be there. What hypothesis? So there must be null hypothesis, which is checked. A third thing is, not only this, we are checking the null hypothesis that says any 2 things are there, any 2 things, minimum 2 things, there can be more also, whether the 2 things are same or not. This is what we are checking for. This is the third thing. Fourth thing, if the p value is less than 0.05, then whatever you are comparing, those 2 things, they are different. If the p value is less than 0.05, it means whatever 2 or more things you are comparing, they are different. So it means it's so wonderful to see that I just see one p value. I don't know what is the scenario, but I know so many things. P value means there is a test going on, some sort of test is there. Only test have the p value, nothing else. R doesn't have a p value. So that's why at this point, I will differentiate between the 2 words, test and technique. Test means difference, whenever we are checking whether two things or more are different or not, any sort of test. Vice versa, whenever any test is there, I told you there is a U test, there is a H test, there is some other McNamara test. You have no idea what this test is, but you can be sure of I am checking any two things and whether the two things are same or not. This I am checking. So this is test. Test means difference. Remember blood test and the sugar test. There is other term called technique. Technique is like R is a technique. There is no p-value, etc. However, if you check whether R is equal to 0, this will again, there are two things. One is R, one is 0. You are checking whether they are same. This again goes to the domain of hypothesis testing. So technique is for the word relation. Whenever you are checking the relation in statistics, any technique will be there to help you. So what are the techniques? The techniques are correlation, regression, all offshoots of regression. They are the technique. But the moment you check whether this effect is there or not there, our test will come into picture. Test and the technique. So I told you thumb rule, p-value less than 0.05 means whatever the two things you are comparing, they are same. That's why when we go for the normality check, how actually they do it. So you have some data and you got every reason that it is normally distributed. So you give it to software. What software will do? Software will find out its mean and standard deviation. And then on the basis of that mean and standard deviation, it will produce some of the values. It will generate some of the values which could have been there for any normally distributed data with those parameters. Now it will check one I have created. I know it's a normally distributed. One is your data. Null hypothesis becomes there is no significant difference between this data and your data. That's why null hypothesis, people say it's a reverse. No, it's not reverse. There is only one formula. There is only one way of writing hypothesis, no other way. And that hypothesis is whatever two or more things you are comparing, they are same. There's only this hypothesis for every single thing in entire statistics. So in the normality, when p-value is more than 0.05, we are happy. Why so? Because when p-value is more than 0.05, it means null hypothesis accepted. And what was the null hypothesis in normality test? That your data is same as that of normally distributed data. In other words, your data is normally distributed. So there we are looking for p-value greater than 0.05 in normality test. But in others, if it is less, then it means whatever things we are comparing, they are different. For example, I am checking for the height of boys and girls. Now, if we look out the childhood, after a particular age, after the teenage, you will find in general, average boy will be taller than average girl. I'm not saying in terms of good or bad or any meaning. It's just a biological fact that boys of 21 plus or this, etc., average boy I'm talking about. So average boy will be taller than average girl of that particular age. So if I'm checking this, so I should expect p-value less than 0.05. Less p-value means whatever two groups you are comparing, they are different. If p-value comes out as greater, it doesn't mean the other studies are wrong. Please remember that. Please remember what we are doing. We are checking on a sample. So if the data comes like this, p-value comes greater than 0.05, while it's a given fact that from everywhere boys on an average are taller than the girls, then I will conclude from my sample, it appears that this is same. I may be mistaken in taking my sample. My sample could be mistakenly taken, or maybe it's worth checking once again. Maybe what sort of characteristics population I refer to, where the height of boys and girls are the same. But whatever our study result says, if it is contradictory, that does not mean the other people were lying or they were just giving the false things. No, it simply says my sample does not subscribe to their opinion or their result. My sample. Okay, please remember that your guarantee is only about your sample. You are not supposed to tell entire thing of the universe. You say my sample behaves like this. That is the point. Now coming ahead, core test. Third one is if you want to do more than two variable, then we use a technique called data frame. Make a data frame. So that's simply data.frame bracket, write the name of all the variables and save it in something like I saved it in D, and then put it into core. So core is either one variable function or two variable function. If you are using two variables, then use both in core. If you are using data frame, then only one will do. So core D, it will give all these things. Another is pairs. Pairs will not give the value of R, rather it will give all possible pairs of scatter plot. So scatter plot is very good. Generally, there are many professors who say scatter plot is the first thing for correlation. I agree to them for two reasons. What are the two reasons? Number one, scatter plot will give you a fairly good idea about the outlier. Remember, outlier is a number which is very away. So you will find rest of the numbers are here. One is somewhat here. You will get a very good idea whether there is an outlier or not. The second thing, most of the time, I don't know, for strange reasons, all the scholars, they work only and only on the linear data. Now, this is very surprising and very shocking. Well, whenever I feel I'm clueless why you are working on the linear relation. You just look for, if I'll ask you any relation that's perfectly linear, forget about the E is equal to MC square, physics, chemistry formula, leave them aside. Social science. Let's take any variable of social science. If the leadership and the motivation is there, I don't know how leadership can improve, but let's say leadership style has an effect on motivation. So whatever style I will do, your motivation level can reach up to a level and then it becomes stagnant. Because I'm not belittling you, but the point is your body and the mind has an upper limit you can do. I give you a simple example. You are there and there is a commando also. Do you think your physical fitness or body same properties as that of a commando who's trained for years? Is it the same? I doubt. It's not the same. Likewise, there are some students that are in Harvard University or let's say in IIM or IITs, etc. Now, do you think your mental acumen is same as that of those boys or girls who are in IITs, IIMs? May not be there. So it point here is if I simply motivate you, you can go to an upper level. Beyond that, it's very difficult for you to go. Shipra, are you able to listen me? Actually, I see everybody is seen as static. I don't know whether you are able to listen to me or not. Okay. Safura said yes, I believe. So you are able to listen to me. The point here is, I'm just saying here that look for the beyond linear relation. Particularly when you are talking in terms of social science, opinions, we always have upper limit. Look for, with the age, love increases. I don't know whether it increases, whether love is variable or constant. Maybe for a new person, you don't love the first person. Okay. Hope you are able to see me and listen me. There's a feedback that video is lagging and some mismatch. Actually, what I did, I am hearing a lot of noise, so I put a lot of obstacles, etc., so that noise is less. I don't know about the noise, but signal is certainly less now because of my arrangements. So that's one issue. Signal is frequently mistaken. Hope you are able to listen me. And I also hope the admins are recording the session. Noise level is the same, but signal is blown. Let me come back. I was saying about the direct means linear and non-linear relationship. The point here is please think in terms of any two relation. like stress has an effect on performance. So if we go on increasing the stress, performance will be down. Performance will be zero, or it will be a minimum level will be maintained. So you will find, I'm not saying it's not possible, but most of the time, most of our social science variables, particularly in the marketing, HR, most of them are actually curvilinear. Curvilinear is which becomes a constant. Please look for age and the height. As the age on the x-axis, height on the y-axis. If I ask you to make a diagram of the same, most of the people will draw something like it increases and then it becomes constant. Your age is increasing, but your height is not increasing now. So the point here is most of the our variables like your satisfaction, your loyalty. So loyalty means you're perfectly loyal. How can loyalty be increased now? So, but problem is most of you are using the linear relationship. That's why now the people are saying check for the non-linearity also. And that's a sort of a mandatory part. The developers of smart PLS are emphasizing it a lot. They say forget about the result. Look at the other things which is important, like check for the endogeneity problem, check for the non-linearity. So there is a Ramsey reset, R-E-S-E-T, Ramsey reset. Again, Ramsey reset is not available in SPSS or eViews or any other software. It's available in RStudio. I have explained it in one of the playlists of Smart PLS. So all these new things are coming. Yesterday I told you that so far we are explaining the scholars are struggling with the reflective and the formative. Now we got one more, composite. Now we have actually the three things. There is a reflective construct, there is a formative construct, and there is a composite. Composite are altogether different, complete new philosophy. And there is something called CCA, confirmatory composite analysis, not available in any of the software, only in the RStudio it's available. So my advice will be, please learn this RStudio. The basic concept is there is a function, there's a package. In the package there is a function, argument, so that whenever you're working with anything new, you should not feel like I don't know that. It's okay if you feel more handy with the Excel, SPSS or other software, but you should know about the RStudio also. So with that, let's start back with the correlation part we have completed. Now we can go ahead with the regression. Regression is very, very simple. Simple in terms of the command is LM. Well, when I learned it for the first time, I thought of it should be REG for regression, COR for correlation, but it is LM, linear model. So it's a linear model. So when we have LM, so is there anything else also? Yeah. So whenever you will go for binary regression, multinomial regression, it will become a GLM, general linear model. It will change from there. LM means it's a simple regression. So linear regression, simple linear regression. Please look for every single word. What is meant by simple? Simple means dependent one, independent one. So there is nothing like complex. There is a multiple. Simple regression, multiple regression. So what is the difference in multiple regression from that of simple regression? Dependent variable is one all the time. When it's a regression, dependent variable is one. In simple regression, there is one independent variable. Multiple regression, there is more than one dependent variable. This is the first difference, main difference. Then there is something called linear or curvilinear. So it could be simple linear regression, y is equal to a plus bx, or simple curvilinear regression, y is equal to log x. Y is equal to log x, it's a simple because independent is one, but it is not linear. So simple curvilinear. Likewise, there can be multiple linear, multiple curvilinear regression. We will talk it in detail maybe some other time. So it's just see here. Hope Shipra screen is visible to you. So without specs also it's visible, Shipra, to you. So its MPG depends on, please look for this particular symbol, the sort of the wave symbol. The wave symbol is represented on the left hand side will be the dependent variable, on the right hand side will be the independent variable. So wave symbol, where you can find it on keyboard. Look at the 1, 2, 3, 4. Immediately left hand side of 1. First there is a sort of a tilt and then there is a wave symbol. You use it with the shift. Shift and that particular key will give you wave sort of symbol. Its name is tilt. So if you directly, do you remember when we are in UG or PG? So we solve the regression and our idea of regression is like this. Y is equal to A plus BX. And our entire endeavor is to find the value of A and B, and we are happy with that. Find the value of A, find the value of B, and you say, I'm happy. This is my question is solved. So likewise, if you work with this LM, it will give you the two values and it will say be happy. This is the intercept 30.09 and this is the value of B minus 0.06. It gives only the two value if you directly use LM. But remember I told you we use an iterative process. The meaning of the iterative process is let me save this into X. Okay, and let me get the summary of the X. So when I get the summary of the X, now I get so many other things also. So I have to run it once again so that you can see it on one screen. Okay, now it is SPSS like output. What it says, if you know about the SPSS, there are the three tables. In the table number 1, there is a R, capital R. It's not small r. It's a capital R, R square, adjusted R square, standard error. Second table, there is a ANOVA. We look at the last column, F and the P value. And the third table, there are the coefficient. So this one is the equivalent to the third table, coefficient. So basically what is done other than these values, intercept is 30.09, HP is minus. Okay, so it has computed whether this 30 is equal to 0. Now, I will tell you one thing. I can't stop, sharing this thing. The point here is, we worked on a particular sample. This is a sample of 32. Now I have a question for you. If I change my sample, this intercept value will be same or different? Shipra, what is your idea? If it is same, just say this, otherwise say this. So it will be same. Okay, let me ask other simple question, Shipra. I have 32 observation and there is a mean. If I add one more observation, Shipra, whether the mean will be same or different? Mean will be same. There are 10 values. For the 10 value, there is a mean. Or let's say mean, forget about the mean. I take the sum of the 10 value. Now, when I add the 11th value, whether the sum will be same or changed. I cannot go below this. This is the first class mathematics I am now talking to you. It will change. Okay. It will change. If I go to the 10 value, I add. So until unless whatever the, if I am adding 0, then it's otherwise. But if there is any other number, the value will change. Certainly the value will change. The value will change, summation x by n. Average will change. Got it, Shipra? When average is changing, it means on the basis of average, I am computing this value of A and the B. If you remember the formula, these are on the basis of average. So my question is, why I should believe you? If you are doing a research, you yourself are saying that this value you achieved at, this value you arrived at with a particular sample. And you are telling me that if you change the sample, the value will change. Yes or no? The value will change for sure. Mathematically, just look for mean will change. Mean will change, everything will change, right? That's okay. It's changing in small decimal place, but value will not be exactly same until unless you add 0 or you add a number which is exactly same as that of the arithmetic mean. The value will always change. Now my point is why I should believe, why I should take your value, because you yourself are telling me that the values will change. So that's why I am not interested. Up to the PG level, it's okay. Students are happy finding out this value and value. Now in research, these values are absolutely of no use to me. At the maximum, this sign is helpful to me that this is a negative relation. As horsepower increases, mileage will go down. That's it. These values are not at all required me. I don't want this. I don't believe this. But what I believe, my belief is in statistics. I believe my friend statistics. So I ask statistics, I ask hypothesis testing that whether there can be any scenario when this value will be 0, or if you take any other value, will it be 0 or it will not be 0? So look for the null hypothesis I am checking. I am checking whether this value is equal to 0. Again, I have to reduce it down. Now HP, it says P value is 1.7 E minus 0.7. Remember, when it's a negative sign, it means the value is very, very small. When the value is very small, I say null hypothesis rejected. This value is not equal to 0. This is the point I was looking for. Statistics convince me. Statistics gives me confidence that you take this value. Don't worry. whatever, if you take as many samples, this value will be something. This value will be something, not always 0.06. It will change. Certainly it will change, but it will never ever become the zero. There can be no sample when this value will become zero. It will always be there. Of course, it depends on the sample size, but this will never be zero. Negative sign indicates that as the horsepower increases, the mileage will go down. Okay, negative sign is helping with that. Intercept will say when there is no horsepower, the mileage will be 30. So we have considered on an average, I have considered a vehicle whose average is 30. So start from the 30. As you increase horsepower, if I'll increase by 10 units, what will happen? The mileage will go down by 0.6 multiplied by 10. If I'll go HP of 100, mileage will go down by 6 units this way. Do you understand the meaning of hypothesis testing? Can you appreciate hypothesis testing is one of your very good friends? It's not something total out of, out of the blue it's coming and it's illogical. No, it's very much logical. It's telling you about the future. It gives you confidence about the future. When you yourself are trapped that this value, when you change a sample of 133, this may not be 0.06. So next question it comes, then how much this value will be? How low it can be, how high it can be. This is called confidence limits. This is called confidence limits. Provided, when this will not be zero, provided there is no outlier. Provided there is no outlier. Here comes the normality into picture. Normality says that if your data, you take considering new vehicles and vehicles, their size, horsepower will be in this zone. If they are in this zone, then what will happen? The values will comply like this. If there is an outlier, you take a road roller, horsepower may be very high, but mileage is very low, then that will change an entire data. But that will be a sort of a outlier. So if there is no outlier, so you can be sure of this value will never be zero. Who told me this thing? This value told me, P value, or look at the T value. So friends, there are 3 ways of checking the hypothesis. Again, I'm telling you, this particular workshop is about how to do it in RStudio. This workshop is not about why. Why portions I have taken in the month of April. I may take it again, but this is about how part. Quickly, let me tell you why part. There are the 3 ways you can check the hypothesis testing. The first, that's taught in the PG. When the calculated value is less than table value, null hypothesis accepted. This is the first method. So always remember, T value is always, table value is always between 2 and 3. The table value of T is always between 2 and 3. Now my value comes out as 6. Don't look at the sign. Sign of test, T test, Z test is not seen. Sign is not seen here. Sign simply means it is on left side or is on the right side. Sign is immaterial. Look at this, value is 6. Table value is 2. 2 means that is the maximum difference we can expect because of the chance factor. Beyond that, it's not a chance. Something is happening there. So it means 6 is greater than 2, null hypothesis rejected. First method. Second method is look at the P value. If the P value is less than 0.05, if P value is less than 5%, we say null hypothesis rejected. Or I told you in plain English, whatever 2 things you are checking, they are not same. What I am checking? I am checking whether this is equal to 0. Then this value ensures me this is not equal to 0. How come 0? Because all statistical test and technique, they always work on the null hypothesis. No difference, or if single value, we check it against 0. Always and always. Only these are the things. Likewise, intercept is not 0 and this is not 0. Okay, so this will now gives me, so if you publish it, nobody is interested in the value of 30 or value this. People are interested whether the P is less than this or not. If they are less, it means your values are good. Look at the rest of the things. The rest of the things are, the second table of SPSS is depicted here. First and the second table. First value is about the R square. R square is, only thing is, since it's a free of cost, so it is not giving you in that tables etc, right? So giving you in paragraph form. Multiple R square comes 60%. It means 60% of the variations of MPG are explained by that of horsepower. 60% of the variations of miles per gallon are explained by horsepower, 60% of that. There is something called adjusted also. I want to discuss it now. I have explained it in one of the playlists. What went wrong with the R square, why people thought it is wrong, and they made adjusted R square. F statistics checks the model as a whole. Well, now here it's the same thing, same this value and this value. So if 6.7, if you do its square, it will become 45 point this. I don't know whether do you know this? T square is called as the F. If you are working on the simple regression, one dependent, one independent variable, the square of T will be called as F. You can check it here. Let me check. 6.742 multiplied by 6.742. I think I have done 0. And it's not only 6.742, it's up to 17 decimal place. So 6.742, it will come approximately 40.456. That's the same thing. So in the simple regression, T square becomes the F, not in the everywhere, only in the simple regression, T square becomes the F. So F value tells me about the model as a whole, and this tells me about the individual one. R square comes out 60%. While reporting simple regression, 4 things are to be reported. What are the 4 things? The first thing is whether the model is significant from the F value. So we'll report here, F value is 45. Can you tell me what is the table value of F? I told you 2 hints. Table value of T is 2 and F is nothing but the T square. So table value of F is approximately 4. Table value of F is approximately 4. Always remember that. Approximately, not exactly. Okay. There's a query that I'm little confused that the value is between 2 to 3. Dear, value of 1.96 is not of T, it's of Z. Z value for 95% is 1.96. So I want you to just pay attention at the T table. Okay, so there, what is there in the T table? The values are there. For the Z, there is only one value, 1.96 for 95% confidence limit. For the T, there are values. When degree of freedom is 1, the value is 12. When degree of freedom is 2, it becomes something else. Degree of freedom 3, it becomes 3 point and then it goes on decreasing. When it becomes more than 30, 60 or something, it becomes 1.96. So if you are confused, though again, it's not part of this workshop, let me show you. I just want you to look at the T table. Pay attention to those tables also. Let me quickly, if I can find it, let me quickly go through that. My system is not in good mode. It seems it's just running and running. Give me a minute. Okay. So this is the table. I want you to just look 0.05, two-tailed 0.05. This is the column. Hope my screen is visible to you. So look at this. When the degree of freedom is 1, the value is 12. When the degree of freedom is 2, 4.3. Degree of freedom 3, 3. Just look at the value. Don't do anything. 2.7, 2.5, 2.3, 2.3, 2.2, 2.2, 2.1. Many are 2.1. Many are 2.0. Quite many, I think rest all. And then when it becomes infinity, it is 1.96. So Z value is 1.96, T got a value. But if you pay attention, it's most likely between 2 and 3, except for degree of freedom 1 and 2. And what is degree of freedom? In case of T, it's n minus 1. So I don't know when will be the case when you will work on a sample of 2 or 3, then the degree of freedom will be 1 and 2. Else, whatever sample is there up to 30, the value is always between 2 and 3. The value of T is always between 2 and 3. So it means, look at this value, the value is 6. And what is our rule? Calculated value less than table value is something like we say null hypothesis accepted. In all my offline workshop, I always say that, you know, you should, by the time of you, if you're a PhD scholar, you please get it tattooed at your hand or maybe at your head, get it tattooed. Because this is something, a golden rule of hypothesis testing, entire statistics. That calculated value less than table value, it means null hypothesis accepted. The second thing is p value greater than 0.05, null hypothesis accepted. Don't get confused between this, you know, get it tattooed somewhere so that this is the cross reference you can all the time. Obviously temporary taboo, not which your spouse will ask after marriage, what is this? Only the temporary, so that you can for 2-year duration. Remember that. P greater than 0.05 null accepted, P less than 0.05 null rejected. What is null? The two things, whether they are same or different. Who will check this? Any of the test will check this. What will be the result? P less than 0.05, the two things are different. P greater than 0.05, two things are the same. Now let's come to the next part. I hope this part, this much regression, you are clear. 4 things we report in regression. The first thing, F value. Second thing, T values. Third thing, regression equation. And the fourth thing, R square. So when you go for the summary of this one, just see, are we getting all the values or not? So this is the first thing, F statistics of 45 and P value very, very less. Model is good. Number 2, for intercept as well as for the HP, T value is large and P value is very small. Good. Third thing, what will be the regression equation? This is the value of A, this is the value of B, and we have to write A plus BX. So it becomes 30.09 minus 0.06 into HP. So I can write it like this. MPG is equal to 30.09 minus 0.068 into HP. This will be the regression equation. What is the fourth thing to report? R square. R square is 60%. So there is no hard and fast rule like R square should be 80% or this percent. It depends from study to study, concept to concept basis. It depends on that. But in general, if one variable up to 25-30%, it's okay. If two variable, if you can go into the like 40, 50, 60%, it's good. 3 variable, we expect to go by 60, 70% preferably. But if it's coming 20%, it's okay. It may be case to case basis. When we work on SPSS, it gives us so many output. Where are the rest of the output? Like confidence limits. For the confidence limits, we can do this either. And where is this beta? Now, beta is something very, very important. Beta is very, very important. So I always say in simple regression, there is this another golden rule. What is the golden rule? R is equal to R is equal to beta. Now these are 3 things. Small r is the relation between X and Y. Capital R is the relation between Y and YC, actual value of Y and computed value of Y, computed by regression. And what is beta? Beta is relation between the soul to soul, ZX and ZY. Listen it once again. R is the relation between actual values X and Y, age of the person, income of the person. What is their relation? That will be depicted by R. I told you there is no way of computing the R until you calculate their Z scores. So actually we compute their Z score and their relation. That relation is called beta. And capital R is the relation of Y and YC, actual value of Y and the predicted value of Y. But this is applicable only in the simple regression, not in the multiple regression. Why so? In the multiple regression, R will be the same, capital R, it's Y and YC, but there will not be any R. Rather, there will be R1, R2, R3. Dependent variable is 1, independent are many. So it will be R1, R2, R3. For every, there will be many R. There is no such R thing. Likewise, there will be many beta. If you wish to compute beta, use the package require lm.beta and put the value. The name of the function is also lm.beta. So if you remember, you can write this. In case you forget what was the name of the function, so write the name of the package, colon, and the drop menu will come, ln beta. In that, put that value x. So this is the beta, intercept not required, HP, it's 0.77. This is the beta. Do you remember what was the correlation between MPG and horsepower? This was again 0.77. So beta is equal to R. This is R and this is the beta. Beta computed from ZX and ZY, R computed from actual Y. There is no way of computing R without computing beta. So R is equal to beta. Where are those limits? For limits, there is another package, lm test. LM test, and It's COEF, confidence or intervals. Sorry, confidence intervals. So this value, what was the value? This is those values. Let me check this once again. LM of this. What was the intercept value? My intercept value was 30.09. So this is telling me the value can be, if you take further more samples, the value can be as low as 26, value can be as high as 33, but it cannot go beyond that. If the data is like this, if that is normally distributed data, there are no outliers, then you can expect, if you take subsequent samples, the intercept value may go 26, as high as 33, but it will not go beyond this. 100%, no, not 100%, 95%. 95% of the time, the value will not go. 5% are the cases it will go beyond that. Okay, 95% we are confirmed it will like this. My regression coefficient is 0.06. Will it will be always 0.06 if I take further sample? No, this can be as low as 0.08. It can be as high as 0.047. 0.047, but 95% of the time it will be between this interval. 5% times it can go beyond that. Hope you understand the meaning of this. So you must know about these concepts. Doing it in R is simple fun. What is the Durbin-Watson test? Durbin-Watson, it's again in the LM test. DW test is the name of the function. Durbin-Watson test is basically a sort of a traffic light. It will say if your DW value is between 1 and 3, then go ahead with the cross-sectional data. If it is less than 1, if it is more than 3, please go for the time series data. There are some autocorrelation in your data. It is checking for the autocorrelation. So DW value in general is between 1 and 3. If the value is less than 1, more than 3, most likely there are the time element. So if you are doing on the survey method, you have taken 500 people, different people never check it. It will always be correct. But you always know when there is a time series data. When you are taken 10 years data of something, it's a time series data. You can check Durbin-Watson, the value will always go south. So it will tell you that this is not the correct way. Go for the time series analysis. Now, some people say, well, this is good. I'm very happy. This is, presenting the data in that format, this format, but I don't like it because SPSS gives me in the table format, etc. It's not giving me in that format. Okay, don't worry that. Let me repeat once again. Durbin-Watson value is always between 1 and 3. So 1 less than equal to DW value less than equal to 3. If it is going less than 1, more than 3, it means your data got some time series data element. There is some sort of, there's a problem of autocorrelation, which is one of the essential assumption of regression, and you must go for the time series data. Those who want SPSS like output, for that, there is another package called JTools. JTools. So if you feel that there are so many packages, no, not in fact. The name of the command was LM, Y depends on X. Okay. The second thing was, instead of doing this, we prefer summary of this Y depends on X. This is the way we will get all output. Then 3 are the packages I told you. LM.beta is one package. LM test is another package. And JTools is the third package. These are the 3 packages I have recommended. What's the purpose? LM.beta will give you the beta value. LM test will give you confidence interval, as well as it gives you actually many things. Confidence interval, it will give you Durbin-Watson value, and Ramsey test is again available here. Ramsey reset. So see, reset. Okay, LM test, yes. This is that Ramsey retest formula, which checks for the non-linearity. Okay, this is only available in R as of now. So 3 things I told you. One is LM.beta, only for computing beta. LM test, it computes the Durbin-Watson value. This is a package. You need to call this package. The functions are Durbin-Watson, confidence intervals, and the third one, it checks for the non-linearity, that is the reset. It's a Ramsey, given by Ramsey reset, R-E-S-E-T. Then third package is JTools. The good thing with the JTools is JTools gives you a very good output, the same output, nothing new, but now it presents in a good manner. Observation 32, dependent variable MPG, OLS regression we have applied. F model for 130 is 45, R square is 60, adjusted 59, and this sort of the little more presentable. Otherwise, there is nothing new in the data. So that's available in the J tools. Okay. If you wish to, you can have the graphical version also for this. So let me show you the graphical part. For this J tools, there is a command plot. Plot underscore COEF. Plot the coefficients. So let me plot the coefficient. What will happen? So look, this is the 0. And for HP, the things are coming here. The rule is, if any of the line, this is the confidence intervals are plotted. If any of the line crosses this 0, it means that particular thing is 0, else it is not 0. It might be that you didn't get it. No problem. Let me explain it to you with something else. Let me quickly go through the multiple regression. I will come back to this once again. Multiple regression in R is so simple. Simply add one more variable. Check it once again. Let me increase its size. What you need to do, you need to simply write one more thing. LM, MPG depends on HP plus weight. It becomes a multiple regression. If you require third one, DISP, add a third one also. You want to add fourth one, DRAT, this is the fourth one. It becomes multiple regression. Rest of the things are the same. So let me check the 4. It all output goes into this and summary of the X. So this comes out as the summary of the X. May not be visible properly. Let me again run it. Now it's okay. HP, the value is 0.03 and it is significant, less than 0.05. Weight, minus 3.47 and it is also significant. Displacement, 0.03 and it is not significant. P value is 0.72. DRAT, 1.76, whether it is 0, yeah, almost it's 0. 0.19. Okay, so one method is you look at the T value, more than 2. These are less than 2. Other value, you look at the P value. Yet another third method is, let's use now the JTool command. I go to the JTools and look for the, it says plot underscore COEFX. So what I'm asking, I am asking, see, do following things. X is given to you. You know what is X. X is the regression output. From that output, you compute the confidence limits, plot them on the graph, and I will manually check if any of the line crosses 0. Those things will be 0. So let me do this. Now check it out. Where is HP? HP is almost 0, very near to that. Weight is not 0. Just look at here. Weight is not 0. It can never be 0, even in this future. DISP is exactly on the 0. And DRAT is crossing the 0. So DRAT is almost 0. Displacement is 0. HP is very close to 0, maybe 0. It's not exactly on the line, but weight is never 0. Please look, the same thing we have concluded from here. HP, look at the value. It's 0.005. It's a 2. Okay. Other values more than 0.05, more than 0.05. These values are 0. So plot is just another method of representing the same, if the value is not 0. So friends, I will request you, whenever you see confidence limits, please read it as future prediction. Confidence limits is always future prediction. It means if I go and take many samples, many samples, my weight value can be as low as perhaps 0.55 or 6. It can be as high as 0.1 or minus 1 point something, but it will never be 0. What about the DRAT? DRAT value will be from minus to this. That means it will be 0. There is no effect of DRAT. Look at the displacement. It's exactly on the 0. There is no effect of this. HP is very near to 0. Okay. So this way you can check these values also. This another method of showing the things. This is available in JTools. So look at how many things we have discussed. Number one, a simple method is you just go for LM. If you use 1, 2, 3, 4, 5, 6, absolutely no problem. R has absolutely no problem with that. You can take as many variables as you like. Okay. Second thing, instead of doing this, save it into X and do the summary of X. When you do the summary of X, what will happen? It will give you F value, it will give you coefficient, T values, R square, adjusted, it will give you all when you go for the summary. That is always good thing. Three things which you require additionally, lm.beta for getting the beta value. Now this is another way of checking. Let me run this and let me run the lm beta. Check whose lm beta is highest. That will be the strongest. Don't look at the sign. Just look at the number. For HP, minus 0.39, weight 0.56, displacement 0.07, drag 0.15. Who's the strongest in the four? This is the strongest, weight. So beta, how to infer beta? Beta, number one, sign is not seen. Sign, don't worry about the sign. If I'll just take example, I want to say I want to increase the profit, and you told me increase the sale. Good, profit will increase. Or somebody say decrease the cost, profit will also increase, right? It means one is positive, other is negative. Don't worry about the sign. Look at the value. Weight got the highest. Beta is whosoever will got the higher beta will be the strong. So who's the weakest among the four? Displacement is the weakest, 0.07. Second weakest, 0.15. Strongest, weight is strong and this is strong. Okay. So beta will give you these values. Then coefficient, it will tell you the future. What is meant by COEF? It's the future. Coefficient, confidence intervals. Confidence interval means future. Run it. The value of DRAT can be minus 0.9 to 4.47. Remember, I told you there are the three methods of checking hypothesis. Number one, calculated value less than table value, null hypothesis accepted. Second, P greater than 0.05, null accepted. Third, if 0 falls between the limits, null accepted. Listen it once again. If 0 falls between the confidence limits of that variable, it means that variable has no effect on dependent variable. That's as good as 0. Check for the HP. It can be minus 0.5 to minus 0.01, very near to 0, but not 0. It is significant. Weight, minus 5.69 to minus 1.26. Put it, draw a line on x-axis. See whether 0 will fall between the limit or not. No. Look at the displacement. Minus 0.1 to positive 0.0. Yes, 0 will fall. Displacement is useless. No effect on MPG. DRAT, minus 0.9 to 4.47. This is also 0. These are the same things which I plotted on the chart. These are the same things. Let me plot it once again. So this plot is available in this JTools. Plot these values. It will say, well, this is the value. Check it once again. DRAT is crossing the line. That means 0 fall between these limits. Displacement is actually on the 0. HP, it appears very, very close to the 0. Very close to the 0. But weight is never ever 0. So weight is the strongest out of the 4. Okay. One interesting thing I always tell, it's not these are completely useless, displacement and DRAT. They are having no effect because of the weight. If you remove the weight, chances are they will be good. This is called multicollinearity. Understanding that why these things are happening, this is multicollinearity. So let me try to show you. It's possible if I'll remove this one and then work on the plots, there are quite chances that these are not 0. It says still both are the 0. Might be weight is there. Let me remove the effect of weight, or it might be they are actually useless. And let me plot it. Displacement a little away or DRAT is almost 0. Well, they are useless in that case, but most of the time they are away, they are kicked out because of multicollinearity. So I don't know how much you understand. It's basically you should know about something, only then we will be more comfortable doing it in R. You know, in all my workshop, I always say that, see, there are two things. Either you say you know R, I will teach you stats, or you say I know stats, I teach you very fast how to do it on R. If you are new to stats as well as R, that's a deadly combination. Learning R, learning statistics using R. At times you need to go on statistics, at times using R. So I assume you know about all these things, coefficient, DW, etc. If not, then you must seriously, you should attend a basic workshop on all of this. Let me go for the multiple regression. I actually shown you, but here I got one more thing, one more surprise for you. Let's see once again. This one is simple regression, right? So there is only one variable, HP, and rest of the data is there. Let me just take, okay, hope it's visible to you, because otherwise the things go so scattered. Let me go for the second one, HP plus weight. This and summary, it becomes now multiple regression. There is a HP which is significant, there is a weight which is significant. Both of them are there. Okay, look for the third one. I want their multiplicative effect also. That is called interaction effect. So the interaction effect in R is so simple. Instead of plus sign, simply write into. Instead of plus sign, simply write into, and it will compute you. It will give you the interaction effect also. Now it is saying for the HP, it's significant, weight is significant, and HP into weight, that is also significant. So this is the same, which people were asking about the moderation. Moderation in RStudio is just fun. It's just so simple. Please remember, the another name for moderation is interaction effect, when the two are, product of the two is taken as a separate variable. So nothing to be done. It's a simple, instead of plus means multiple regression, into means you are checking the interaction effect. That's simple. That's simple. If somebody is interested in knowing about, there is something called stepwise regression. We must know about the stepwise regression. Stepwise regression means out of the given 5 or the 10, then which particular variable is the best one, followed by the next one, then followed by the next one, and that sort of stuff. So that's again very simple here. Here what we'll do, so I will, let me take the two things. The two things are, number one, I am running without any variable. So please see, please look at it, how I'm doing it. You must understand this. I am doing it first, MPG depends on 1. It means no variable, only constant. The second thing, I got a long list, HP, then WT, then displacement, then DRAD, then QSEC. I have taken the 5 variables. Now I want, out of the 5, what is stepwise regression? Stepwise regression say, tell me which one is the best. Then in the presence of first, which one is the second best, then the third best, fourth best. Give me the hierarchy, give me that sequence. That is called stepwise regression. Let's do it. It's so simple here. I made it as S1. Before that, let me tell you one thing more. I forget to tell it to you. Let me run X. What is a X? X I am taking as the simple variable. MPG depends on HP. Okay, this is X. And let me run Y. MPG depends on HP plus weight. This is also done. And now if you want to check that whether this weight is contributing significantly or not, whether the weight is contributing significantly. Remember, there's a first one, there's a second one. Then we can use a command ANOVA. ANOVA, it's not one-way ANOVA. One-way ANOVA will be, command will be AOV, analysis of variance. ANOVA means it's for the model checking. I am checking, please remember once again, what is X? X means, I know I'm very fast. X means LM MPG depends on HP. This is X. Let me run it. The value goes into the X. I'm not looking at the summary. Y is, what is Y? Y is MPG depends on HP plus weight. This is also done. Now I want to check whether there is an improvement in the model or not. How to check? So RStudio will say, I will check on the basis of residual. If residuals are going down, then it means your model is increasing. So what we will do, ANOVA XY, check it out. It says in the first model, residual was 447. In the second model, it becomes 195. There is an improvement of 225, and that is significant. So model is contributing good. So this is what is called as hierarchical regression. So again, coming back to the same point, that first you must know about the regression and the all types. Doing it in R, it's simply fun. It's very, very simple. I will take the questions little later. So ANOVA, You understand? Just let's. It might be quite confusing to you now because there's so much happening now. Let's write it one again. Let's revise so far. I think we got 27 minutes, but no worry. Let's revise quickly. Correlation. Number one, COR. It will check only two variable. Number two, COR dot test. It will give the relation plus it will give you the what? Null hypothesis whether the R is 0 or not. Number three, core of D, where D is a data frame. This is X and Y. So this will check for entire data frame all possible things it will check. The fourth, pairs D. It will give you scatter plot of all possible scatter plots. These four are available in the base package. You have to get a package require or library Psyche, and in Psyche we have core.ci and put the D here. It will give you the heat map. Okay, so let me write here hash. It is heat map. This will give pairs. It will give me what? All possible scatter plot. Okay, rest you know what they are. Let me write for the regression quickly what we have discussed in the regression so far. Number one, basically it's LM linear model, but I will write directly. We always work on summary LM y depends on x. Let me call it as x1. This gives me simple regression. The three tables it will give. It will give me what are the things it will give me. It will give me f value. It will give me t values which we have to report. F is a single value, t for intercept as well as all the possible variables. Third, it gives me the value of r square. It gives me adjusted r square. You can write regression equation from here. Summary this. But what it will not give. So for the number two, you need to work on require lm.beta. Same is the name of the function and same is lm.beta. Now in that beta, what we will write this particular thing. Now actually I have to write it separately. Let me call it as Z, and here I will write as summary Z. So this Z will be used again and again. I will not write this complete LM this. I will save it in Z and Z will be used again and again, like summary Z, like LM beta dot Z, right? Third thing, I want, what is this for? This is for beta values only. Next thing, I do require what? LM test. What it is used for? It is used for three things. DW, that is the Durbin-Watson. Let me check whether it was the same. You see, I've been using it from 3 years, but I don't remember. And never I feel that I should remember that, because I know I will write it as LM test colon, and then I will search from it. What was the test? Okay, so I never remember it. So need not to remember. It's a DW test, Z. Okay, second, reset. RESET, What is this for? This one is for checking the non-linearity. I'm not discussing what is non-linearity here. What is this for? This is for Durbin-Watson. What is the spelling of Durbin-Watson? Let's check that. Durbin and Watson test. What is this for? This test is for checking the autocorrelation. So please don't worry about the autocorrelation. The people who are collecting time series data, they should check about it. Durbin-Watson test. Okay. Anything else it checks for? Yeah, it gives one more thing, and that is it gives us the coefficients. If you want this, so this one I will copy. Chad, what this will give me? This will give me. Hope my screen is visible to you. So what this will give me? This will give me limits. Let me call them as the limits. And the rule is if the 0 falls between the limit, whatever variable you are checking, that's no good, no effect, useless. And the fourth one I did for require J, its name is J tools. Yeah, J tools. J tools. What is this used for? Two are the purpose. One is SUMM. Remember earlier it was summary. Now it's SUMM only. It gives a SPSS like output. Very systematic, neat and clean, all the things in place. It gives you that. And the second thing J tools will give you, it will give you plot option. Let me copy from there. Plot the coefficients. That can be very, very helpful. Jet. Okay. So these are the four things in regression and the correlation we discussed. So in general, the first is enough. But if you are looking for the additional things, if you know their meaning and want to report beta, Darman-Watson, nonlinearity, these are all the part of the assumptions actually. If you know about them, then report it. I told you only three. There can be so many functions. Anything that comes to your mind, can it be done? Answer is yes, it can be done. Only ask how it can be done, which package. Anything you think, can this be done? Yeah, everything can be done here. Additional thing for the moderation. For the moderation, what we will do, we will simply do it as LM y depends on x1 into x2. This becomes a moderation. Obviously, you will find summary of that. Okay, let me call it as M is equal to this or mod is equal to this, and then you will do summary of mod. Right? Anything else? For checking hierarchical regression, I don't know what will happen to my research babies. Yesterday I told you this is for research babies, and today I'm talking so technical things because today is the introduction to R. I don't want you to get an idea that R is weak. R is super strong. So if you know about these things, then perfect. Otherwise, first you know and then work on the R. So how to work on the hierarchical regression? In the hierarchical regression, what we work with, what is hierarchical regression? I simply want to know that whether the second variable is contributing something in the presence of first variable. How to go ahead with that? So let's say A1 is equal to LM y depends on x1. This is my first one. Then I say A2 is equal to the same, but here now I have added plus x2 also. And I want to check whether, sorry, it's A2. I want to check whether there is any improvement. The command is ANOVA A1, A2. That's it. And it will check and it will report back. So how to check here? What you should look for? You should look for if the p-value is less than the same one, only one result is there. So this becomes your sort of crack sheet. All these are on one page. That's no issue. I have already given you this second script. All the things are written there. You don't to worry. You will not forget. Just download it from the link given by Suman. So it becomes like this ANOVA we discussed, and last part comes as the stepwise regression. After the hierarchical regression, last part is stepwise regression. What is stepwise regression? A part of multiple regression when there are so many independent variables and you want to find out which one is the best one, followed by second, third, and this way in their hierarchy. Name is stepwise. How to go ahead with that? So I made first one S1. MPG depends on no variable, only one. Second, I said S2 depends on so many variables are there, so many variables. Then let's run that also. And now this is the third thing. Please note it down how to write. There are the three things. First, I will say S is equal to step. It starts with S1 when there is no variable. Then we say scope. This is a particular way to write. Scope, list, lower is S1, upper is S2. Start from lower to upper, go like this, and direction both. Okay, so there is before that you must know there is something called the forward method of regression. There is something called the backward method, and later stepwise method was devised. If you know about that, only then listen. If you don't know, then check your WhatsApp message. So let me run it. What is the output? What it says? Look it from here. It says I started with 1 and AIC. Now AIC is one of the criteria, Akaike information criteria. It says it's 115. Okay, now I go ahead and only point is this Akaike criteria should be lower. until it will go low. It's a sort of a residual. Think in terms of residual. The lower this value, the better it will be. So it says initially I started with it. Okay. Then what's next? Then it said, then I checked for the second thing I propose is the weight. Weight is the best in all. Why weight is the best in all? Because with the weight, it can go from 115 to 73. With displacement, it will go to 77. HP, it will go 88, 97, and so on. So out of these one, I prefer, means R is saying this. I'm saying the dialogue so far. So R is saying, I advise you to go with the weight. Weight is the best among all. They said, okay, weight taken, MPG depends on weight. What's the next? It says then, now criteria is 73. Now, if you take HP, it becomes 63.8. If you take QSEC, it becomes 63.9 and so on. So here it says, I recommend the second one is HP with the weight. So we said, okay, MPG is weight plus HP. What's next? Now it becomes 63.8. It says, if you go further, nothing else will improve. None. There is no, because if you add anything, actually this AIC value will increase. So nothing, it says this is the best combination. Rest all are useless. This is called as the stepwise regression, particularly very, very helpful for all those guys who are working with the multiple regression with so many variables. Because of multicollinearity, they will be kicked out. There will be clashes within themselves. That's why you will just throw out and ask it which one is the best combination. But again, you need to work on this particular syntax. You need to remember, or this is available with you in the script. Step, we start with S1. What is S1? No variable and all variables. It says go, scope, lower, upper, and direction both. It will give you this way. Just look at the AIC value. So let me run it once again with the, I hope now it's better visible in one place. So best one is 115, can be reduced with the help of the weight to 73. First preference is given to weight. With the weight, second preference is given to HP. QSEC is also very close to, but HP is lower. But when you take the both, where is QSEC? Now QSEC will actually increase. When you have taken HP, QSEC will actually, because of multicollinearity, it's kicked out. This is the best combination you can take. So with this, I stop with the regression. Regression is complete. Simple, and the multiple regression is complete from my side. Now I can look at your chat box and what are your questions are there. Need to attend the qualitative workshop. Okay, for interview documents. Maybe in the future I will take some workshop. I have already made a detailed playlist on RStudio for text analytics. What you can do in the text analytics, generally, though it's not the part of this workshop, we generally do one sentiment analysis. We make the word cloud. We put, you will be surprised to know, we can find R between the words. It means that whenever this particular leader speaks this word, what are the other words he always speak along with this? We also find R there. That's called a relation between the words. So we can find that also. I'm learning these days applying factor analysis of text data. This is something, a very novel thing, which I have listened for the first time. So it's a factor analysis on the text data. So it's not that if you go to the interview question, you can't do anything. So many techniques are available. Courtesy R, it's just so simple. So there's Dr. Vivek is saying, I'm not able to register on website. Suman and team will take care of that. Don't worry about that. Any other thing? Stepwise, too statistical for real life predictions. Stepwise, not too statistical for real life prediction. No, Safura, it's not like this. Actually, see, Safura, the main thing is to understand is the multicollinearity. Safura, please understand, stories always becomes from villains. If there is no villain, then what the hero will be doing there? So villains are most important. Pay attention to the villains, and there are only two villains so far we discussed. One is outlier and second is multicollinearity. Every single thing, Safura, is a case of multicollinearity, where what you call as the mediation and the moderation are other name of multicollinearity. So if you know multicollinearity, everything can be done. So now coming to second point, she is asking that isn't it too statistical for the real life prediction? Absolutely not. Absolutely not. They are related. Take an example, Safura. When I say height depends on age, height depends on genetics, right? You believe this? Height depends on genetics also, height depends on age also. But do you know age and genetics are also connected? You had the same sort of DNA right from your childhood. Then why you are born this much? Only in your teenage you become this much height increase. Why so? The DNA was the same, but remember those sort of hormones change, etc. at particular age. So age is also related to that heredity part. On some particular age, those will fructify. Now, what will happen? This Safura I always show in my workshop. You know, you take one variable, MPG depends on horsepower, R square comes 60%. Take another, MPG depends on weight, R square comes 50%. So my point is, if I take both, one is 60% R square, other is 50% R square. If I take both, will it become 110% or at least 100%? When you take both, actually it becomes 61%, not 110% or 100%. Why so? They have something in common, multicollinearity. So the more variables, Safura, please remember, there is a golden rule. You will never ever have 10 significant independent variable for any damn dependent variable. I'm saying it on, it's not written in any book. I'm saying it on the basis of my experience of 2 decades of with statistics. It's very, very hard to get 10 significant independent variable. Very hard. Reason being, they will automatically be correlated. And particularly look at the scenario when we talk about social research. When I ask leadership, where is leadership? Here. The idea about that leader is here. Performance is here. Organization, culture, politics. This is not happening. This is not tangible. It is here in the mind. And in the mind, remember, everything is in the chemicals and everything. Multicollinear, full multicollinearity inside the mind. Everything is stuck up. So it means it's not that real life, it's a disconnect. Rather, it's a good thing. You take so many variables and you will automatically say, no, no, other things are kicked out because these are more important. This is a blessing for us. We need not to remember everything. We remember only few very important things. Otherwise, we'll get a brain hemorrhage. So stepwise regression is a wonderful thing in the real life scenario. Okay, there's some query from Rajat. I want to learn where Arch, Garch, many other thing. Wonderful. I strongly recommend go to the channel of Miklesh Yadav, Miklesh. Go to the channel of Miklesh Yadav. He has already taught this. And Miklesh once in a month takes this free workshop. Where is he? He's in FIIB Delhi. Anyone can go to his means earlier in the offline, anybody can go, no registration fees, no charges, nothing, free of cost. Go and learn from it. Just a little Santa Claus Miklesh is. So go to the YouTube channel of Miklesh. He has explained all, and he will be more than happy to help you for any query. We all people, we feel very happy if we can help you in any way. Okay, any other query? How to identify independent and dependent variable? Well, that's a $1 million question. How to identify dependent? See, this is precisely what is research, what is review of literature. What else you are doing in the review of literature? So I say there are the three. I always tell there are the three criteria. Criteria number one, common sense. Common sense, like age depends on height or height depends on age. So you will say, we can't say that a height is 6 foot, so age must be this. No, but we can always tell if height is 15 years, age must be this, height is 60, age must be this. Sorry, height must be this. So which is dependent, independent. Second thing, there is such a variable you are absolutely clueless. No problem. You are not the first person who is doing it. There are other experts in this area. Ask those domain experts. Okay. So for the PhD student, I always say in the expert, write my guide. Ask your guide about that. So these are the two, and third is go for the review. There are chances. That's what the maximum people are doing today. Maximum people are today. They are talking about this problem. The name of the problem is endogeneity. Everybody is talking about this. One is endogeneity, and second is CMB, common method biasness. These two are the hotcakes. Everybody is talking about this. Endogeneity, the meaning of endogeneity is there can be more than one relation. What sort of relation can be there? The relation can be it can be like A leads to B, but B also leads to A. There is a reciprocal relation, or A and B both are affected by C. So I will share you one link. There is one professor from France. He's a professor of organization behavior. He has actually popularized this concept of endogeneity. An outstanding video is there on YouTube where he, with the help of a lot of animation, etc., he explained this problem. And solution to endogeneity problem is actually 2SLS, two-step least square regression. Two-step least square regression is one of the method of coming out of the problem of endogeneity. So I will share that professor's video. He's, by the way, again, editor of several journals. Okay. There is another question. Is there any method to solve at a time two or more independent variable or two or more? Kiran asked this question. Kiran, what do you mean by solve? What is solve here? We apply any of the test or technique. There is a t-test, regression, correlation. I didn't understand the meaning of solve. Maybe you want to say something. Please write that. What is the difference between hierarchical regression and stepwise regression? A very good question. Stepwise regression means these are the 5 variable, 10 independent variable. I give it to system and ask that you tell me which is the best one. This is the best, then second best, third best. Give me the hierarchy. Hierarchical regression means I will tell to the system that this is first variable, then compulsorily check this variable and tell whether improvement is there or not. So please remember, whenever we are working with, this is a combination. Whenever you are working with what? Control variable. Whenever you are working with a control variable, we always work with what this is called hierarchical regression. So control variable and hierarchical regression, they go hand in hand, vice versa. So if you are working with a control variable, compulsory you have to use this. What is meant by the control variable? Control variable are those independent variables which affect the dependent variable, number one. Number two, you cannot take away its effect. The example is from your height, I cannot take the effect of your age today and your gender from, I cannot take it out. This will be there. Okay. Number one, these are the independent variable that affect DV. Number two, I cannot remove its effect. Number three, I don't want to study it. I know it affects, but there is some other independent variable. Okay. So from that perspective, look for effect of Bornvita on the height. Dependent variable is the height, independent is the Bornvita. But your age and your gender is also affecting the height. So these will be called as the control variable. I will do it in 2 steps. What are the 2 steps? I will say step number 1, find the effect of CV on DV. And then the second will be find out the step 2, find out the effect of IDV and plus CV is also there on DV. Now, if IDV is still significant, it means it can still increase something in the presence of control variable. If it is not, then it means IDV as useless. Shall I give you a lighter example on this side? So I told you yesterday that I asked one of my friend, she recently, student, not friend, student. So she recently got married. I asked, how is the married life? So she said, it's a fantastic. My husband is very good till my mother-in-law comes. So just take mother-in-law is the CV here, wife is the IDV, and husband is the DV. So there is a huge effect of CV on DV, which the girls typically say mama's boy. So mama's boy is the effect of CV is so much that whenever the CV is present, effect of IDV becomes almost 0. But if CV is not there, then IDV got an effect. This is control variable. How to check it in 2 steps. So that's why we will check it using the hierarchical regression. Hierarchical regression, we provide first check this, then this, then this. Stepwise regression, we give it everything to the system and say, you tell what is going to happen. So it's only the manual intervention is there. Okay, then any other example? I appeared Excel sheet of response through Google form. All are non-metric data. Okay. I told you yesterday that if you are on the Google Sheet, what do you need to work for data? To enter that data, that's very important. Maybe I'm thinking of making a separate video on because this question I have not addressed in my video, and this is asked by n number of people. I'm working on the Google Sheet. I'm facing the problem. So how to go ahead with SPSS and R separately? I will make a video for that. It's difficult for explain those steps here, but I will try to explain this. There's a, can I say example, Kiran continues, there is one dependent variable, more than one independent variable. Can we use multiple regression? Okay. I don't want to threaten you, Kiran, but I shown you table number 1, I showed you table number 3. Deliberately, I have not shown you table number 3, table number 1 and 2, univariate, bivariate. Multivariate is very big. What is multivariate? Actually, try to understand. Independent more than one, it's multivariate. Dependent more than one, it's multivariate. Both are multivariate. So when, particularly if I'll say about the independent is more than one, there are 6 techniques available here, Kiran. So what are the techniques? Just a higher version. Simple regression will become multiple regression. Again, do's and don'ts are there. It's not simply take more than one, it becomes a multiple regression. There is something called ANOVA. There is called two-way ANOVA, three-way ANOVA also. There is something called ANCOVA also. Then there is something called logistics regression also. There are so many techniques. So maybe this is not the right time on that day 2. If you have some query, we can discuss it later. But I told you there is a playlist. The name of the playlist is Beyond ANOVA. Please watch that. If your any of the variable is non-metric, independent variable, any of the variable is non-metric, then compulsorily we have to go for the one-way ANOVA or that stuff. Only when you got more than one independent variable and all are metric, only then you can go with the multiple regression. All DV as well as all independent. Like the case I am discussing MPG, that's metric, HP metric, weight metric, DISP metric. I have not taken any of the non-metric. But if I'll say HP plus cylinder, remember cylinder is non-metric. Now this should not be the LM, rather this should be the case of AOV. It becomes case of analysis of variance. Exactly this much. We'll discuss it in the second half, analysis of variance. So a simple answer is, Kiran, it's not simply more than one become multiple regression, not like this. It's like simply when 2 are there, it's not a regression all the time. There is the tree test also, there is an ANOVA also, there is a cross tab also. So you need to attend again the basic workshop, which technique to apply where. But one thing, if I tell you, you want to believe me, whenever we say, I have done it, let's take a workshop on basics. I don't get more than 5 registration, because these days everybody want to learn only and only SAM and the smart PLS. It's something like everybody is interested, help me in making the 10th floor. Then I ask, okay, is there foundation? No, there is no foundation, but I will start with the 10th floor and then I will go downwards. I don't know what is your idea about research, but you must understand the most important thing to me, it's variable and measurement. Measurement is at most important. Then if you understand number of variable, how to write objective and what is measurement, all doors in the statistics are open to you. But otherwise it will be very difficult to understand. It's not that simple. More than 2 means multivariate. Multivariate, there are so many techniques are there. So it's already 1:31. There are so many questions. I'm not reading the chat box. That's why. Can we use R for smart PLS? 100%, sir. I told you that there is something called, okay, Rupinder is asking. Rupinder, I told you there is a playlist PLS PM. You just browse. I think the problem is there are 42 playlists. Even I am not able to get this. So I will share you a page also where I have make a flow chart where all the videos are there. I got now more than perhaps a 42 playlist and 700 plus videos. So the name of the playlist is what is the name of the playlist? Smart PLS or something like PLS using RStudio. The name of the playlist is PLS using RStudio, and the name of the package is PLS PM. 10 videos are there. Whatever you can do in Smart PLS, everything you can do with RStudio. Please be sure with it. Can R replace PLS, etc.? Well, replace means those companies will be closed. No, it won't replace it. They will coexist. The companies, see, IBM is a company that's a giant. who can close down that. So IBM is also there, but RStudio will also work. And these things are not actually fighting. These people are not fighting. In my SPSS, I have integrated RStudio. So R commands, I need not to go to the RStudio. I can work on this on SPSS itself. But for that, you need to purchase SPSS. Only then those options are enabled. Pirated versions, that's not available. I think other questions, I'm not going this, or there's some, okay, I'm not taking other question. I'm very, very sorry for that, because I need to rush for taking a lunch, and maybe we can again sit in the evening for the questions and answers. So now I will left out only with a few things, the concept of t-test and ANOVA. There I will talk about the one-way ANOVA, two-way ANOVA, three-way ANOVA, and all this. There is a question, quick question is that where to use the dummy variable. Dummy variable is a way to include non-metric data into metric to make your life more complicated. So far I said whenever it's the non-metric data, take it to the zone of ANOVA. Metric data, take it to multiple regression. But there is a small tunnel also in between that. The tunnel says if you got a non-metric data and you want to apply regression, consider it as the dummy variable, then you can do that. But dummy variable itself has some pros and the cons. There is a concept called a dummy trap. You may actually end up in very confusion. I have explained in the regression playlist. The name of the playlist is Regression Simple and Multiple. There, I think 2 videos are there on the dummy variable, how to make the dummy, how to interpret it. And again, in the bivariate, when I explained that R is T is equal to F, all are the same. There also I use the dummy variable for me. So let's stop here. We'll meet at 2:30 for the next session on hypothesis testing, t-test, ANOVA, one-way ANOVA, two-way ANOVA, and all this. That requires a detailed discussion because so many assumptions are there. Let's stop here. Thank you, everyone. Bye for now.